So this exercise is the very first time we put in the course for this hands-on workshop. So it is intended to get you more familiarized with the different compilers available on JASMIN, how to use them, and how to be able to compile a serial code on Lotus as well as on the side. So I think the tasks 1 till 3 is, I think everyone has gone through. I mean, one thing to mention here is that Intel compiler, the different versions of Intel compiler are available, and the GNU compiler is available via the JASMIN environments. Just to be aware, there is an old version of GNU that is not maintained, which is available on the system. So I would recommend user to use the GNU compiler available via the JASMIN environment. So the task 4 to 5 shows you how to invoke an interactive session on Lotus, which means you will have access, you'll be logged into a Lotus node on which you do your compilation and testing. And then you go, you exit that node, and then you do prepare your job script that will be submitted to the batch. New stuff that I've added here is the different node type. Well, initially you had worked through Site 3, 6, and 8. These are the physical machines, these are not virtual machine. Site 3 and 6 are AMD type, and Site 8 is Intel. The reason I want to show you that you can compile a serial code on this physical machine, but not parallel code. Parallel code has to be done interactively on Lotus, and that is on the next exercise. So, and then you have another way to do it. You can do it interactively on a Lotus node. The task number 6 and 7, these are things that it's from the help desk queries that we had in the past. Sometimes a binary is compiled by someone else and is passed to some users, and they run the job and they get some errors. And sometimes this error related to how the binary was compiled. And sometimes those binary are compiled to run in a specific CPU processor. So, and I think the task here just give you an example of how that there are many compilation flags that can be used. This is just an example that I've used Ex08, which is an Intel instruction set, which is specifically Intel dependent. So when you go through the exercise, you've run it on Site 8, it did work fine because Site 8 is an Intel machine. So when you move and run this binary on the Site 6, you get an error. So I'm going to go to the cheat sheet to show the error message. That jumps further. Yeah. So when you go to a Site 3 here, so Site 3 is an AMD. So AMD stands for Advanced Micro Device. It's a different technology, and I mean, I wouldn't go too much into detail. I mean, Intel and AMD. AMD is cheaper than Intel, but Intel has more performance and so on. So let's not talk about this now. I'm just talking about in terms of compatibility of binaries compiled on Intel. So the reason here, when you move to a Site 3 and you run your executable, you get this error message. So the executable won't run, because it will look at the CPU. The CPU is not an Intel, it's an AMD, and it doesn't support these instructions. And sometimes what happens, some applications are compiled with some specific flags, and when they run on the batch, you get job failed. And this is what you get as an error message. So this is an indicative that the binary is not compatible to run on that host, and you need to specify the family of hosts that can be compatible to run an Intel targeted binary. So I've shown, I think later it would be to use the flag -- constraint. So this is just an illustration that interactively on two machines, Intel code that has been compiled with this specific flag won't run on AMD. Outside this, if you compile without any specific architecture, processor model, and so on, it will be fine because you can compile on Intel, running on AMD, and vice versa, but without any specific flags. The last task is, this is an additional task just for you to be aware that the GNU compiler, the JASMIN environment, we have a netcdf installation with the Fortran binding. This is just a netcdf serial library. The parallel one is still not, I think there's someone who's working on providing installation. It's not yet available. But this is just to show you that when you use the netcdf library with its Fortran bindings by the JASMIN environment, make sure that you use the conda prefix environment, because this will set the path to the include and to the lib library. And this is just show you an example on how to link and compile and link your code. Make sure that you have the linking of the library and the bindings in this order. Otherwise, if your example is you put netcdf netcdf before netcdff, that you will get an error because it won't resolve the module, the .mod files. So I'll move on now. So this is for the task listed on here. So there was questions that we put. So I'll put just 4 questions. I mean, there could be many questions here, but these are kind of essential after this exercise, after this task. Is it possible to run a serial function that was compiled on a different system? As I said, the recommendation is to recompile the code on JASMIN rather than running the same code, because it will, and majority of the time, it will fail at runtime because of library not being there, not being the same version, and so on. So recompilation is recommended. So in this exercise, we use the workshop partition and with the Slurm account called workshop. The reason is because this workshop has high priority. So when you submit your job during the event, you get the job quickly submitted. But if you want to rerun through this exercise outside the events, so the queues that are recommended for short for serial code, what I mean by serial, there is just a one core, single core. If every task in the code is done sequentially, then you can use one of the serial queues with the test if you're just testing. So when that test has a runtime maximum of 4 hours. And if you're running for your production, you can use the short serial or long serial depending on the runtime. Another question that I added, so it would be good to mention this, why my Fortran code is running slow. We had in the past queries, people reporting that code run fast before we switch it from LSF to Slurm, and now the code is running slow. So this happened for 2 reasons. First, the main reason could be that the job requirements, the resources that was specified, are not adequate. And in the past, on LSF in the old system, when the job exceed the resources allocated, it was allowed to eat up too much memory or CPU. So there was no limits. Now on the new system on Slurm, we have what we call the C controller interface. So what's the C controller interface that we won't be aware of it. It just, the code will go slow, or you get an out of memory if the code starts can't start eating up more memory that is allocated. So if the code, for example, you think the code is serial, you compile it, or you got a binary, it is still not easy to find out from a binary whether code is purely 100% serial, because unless you have to check the source code. So you run the binary and then your code is very slow. So as I said, it could be that the binary is not actually serial. It might have some IO, parallel IO writing that is not supported because it will try to run more cores, while the allocation was to one core. It could be that the memory allocated is less than what the job requires, so it will try to use more memory, and the controllers will stop the job from using memory, and the job get killed with an out of memory error message. Or it could be that the code is slow because there is trying to access some file at busy times, and there's the IO waiting is gone higher, and it can even get overtimed. So this is kind of an example of scenarios when your code is running slow. I added another question here is, can I use the GNU compiler via module avail? If you do a module avail, actually GCC, so there's a typo. There are some, I'm just going to go to the terminal here just to show. So if I do module avail GCC, and I can say why they are there. So we have three modules here, more modified. So we have the GCC compiler 7.2, 8.1, and 8.2. These has been exposed just to support the MPI implementation that was built using the GCC 8.2 compiler. And we're not maintaining this. They're there when you use the MPI GNU. But you can use them if you want to compile, but don't expect that the GCC compiler is going to be upgraded at some point. So we're not supporting that. Any request, if you want another version of the GNU compiler, it has to be contact the help desk or raise the GitHub support tickets, and then that can be someone will look at it and try to implement it in the next release of the JASMIN package. Move on to the to the review. So I think now you're more familiar with compilation and execution in 2 mode, in interactive mode, and in batch modes. One thing to keep in mind that compilation has to be done interactively. We don't want to have jobs that do compile the same code many times, especially if using Intel. There's a limit on the license. In terms where you keep your source code, the Kubernetes could be in your home directory. You can compile the code in your home directory, or you can compile it in the group workspace, because the executable is reproducible if accidentally get deleted. But it's always good to keep all the detail of the compilation in a make file, for example, if you want to go have it all the time there, or maybe just comment it out in your bash script that the source code was compiled with such flags, because it's always good to have to be able to trace back how the binary was generated to reproduce a result if you need to. One important thing to mention here is that there is some default setting with Slurm when it comes to the memory and the runtime. So if the runtime is not specified and the memory is not specified, the default will apply, which is 1 hour and 8 gigabytes. 8 gigabytes, there is a plan, we're going to reduce this to 4 gigabytes in the future. But my advice in terms of improving the wait time of your job in Slurm, make sure that the memory is estimated and the time is estimated too. The reason being, if that will increase the chances for the job being picked up by the backfiller scheduler. So the backfiller scheduler will find out some empty spot, short time, and some hosts that have little memory. Sometimes the hosts are reserved for long jobs, but they have still some memory and it can fit your job. So the backfill scheduler will pick up your job and schedule it to run on that host that is already reserved for a long running job. In the example of today, I put a note. Just going to go back to it. Here. Oh, I forgot to mention one thing. When you expect the error job, the job standard output and error 5, this message here is CPU bind mask. So it's just an indication on which host the job was submitted. So in fact, it's not an error. But we will try in the future to change the configuration so this error file stays empty, because some processing chains, some others use this error file to check whether the job was successful or not. So this will change in the future. And here I put a note. This is a very short task to be considered as a batch, because we're looking at 5 minutes. And when you look at the job, it does it in seconds. So is that really, does it work, the overhead of the communication with Slurm and the scheduler to run this job? No, it doesn't. So it's better run a short job as an interactive task directly on the side. And if you have repetitive tasks that you want to run in a batch, it is better to group this task all together in a one single long task that at least has a runtime of half an hour. And I explained that so we're making efficient use of the Slurm and loaders, because there is an overhead of Slurm communication. It's give you that it is easy that you give to Slurm and Slurm will find the host and do all the rest for you. But also there is a communication time overhead that becomes very significant if you are submitting hundreds of jobs that are very short run. That's going to put a lot of strain on the scheduler. And this is what happened actually last Saturday with a user who submits quite a lot of jobs that are very short run, and then affected the Slurm scheduler. So I think I've covered most of it here, maybe not a bit on the AMD. Oh, I'll come to this one. There was in the task 5 there was a suggestion to change the constraint to AMD. So this is a new feature that we've added since the last patch to JASMIN. So I thought it'd be nice to add it here. So this is kind of to familiarize yourself with kind of error message you can get if the job fail at submission time, because what it'll do, the workshop queue doesn't have any AMD. It's a pure Intel nodes. So you get some error that bad job failed, no configuration is not available. So this means that you cannot run on AMD on this queue. You can try it with a short serial queue and it will run, because the short serial queue is a mix of AMD and Intel nodes. There is how are we doing with time? Oh, 11:30. I think I'm going to stop here. If you have any other question, maybe you can do them now or later for on the next Q&A session. I'm going to stop sharing my screen, Poppy.